Welcome to our trigonometry series. Today we will start with section 1.1 and we will discuss quadrants and unit circle. But to start, what is trigonometry? Trigonometry is the branch of mathematics concerned with specific functions of angles and their applications to calculations. Well, that's a lot of words. What does that really mean? Well, from ancient Greek, trigonometry breaks down into triangle and measure. So at the end of the day, we're really just measuring the angles within a triangle. And to start, let's look at our xy plane. Going left to right is the x-axis, and up and down is the y-axis. In doing so, we have cut this plane into 4 quadrants. The upper right is quadrant 1, the upper left is quadrant 2, the lower left is quadrant 3, and the lower right is quadrant 4. So for all points in quadrant 1, both x and y will be positive values. For all the points within quadrant 2, x will be negative and y will be positive. For all the points within quadrant 3, both x and y will have negative values. And in quadrant 4, x will be positive and y will be negative. So let's remove all of that and draw a circle. A circle on the xy plane that has a radius of 1 unit and is centered at the origin, where x and y are both 0, is called the unit circle. Let's zoom in a little bit on this. Here you can see it touches the x and y axis at all of the 1 and -1 points. The red line denotes the radius, which is exactly 1 unit long. If you can imagine, this radius can rotate around the circle. In this example, it is rotating counterclockwise from its starting position along the x-axis. Let's say that angle is 45 degrees. Now you may notice a weird symbol. This is the Greek letter theta. This is referred to angles or angular rotation in trigonometry. Let's jump to the whiteboard and do some quick examples. All right, we're going to try to draw an x-axis here, like so. Put some arrows on it. Over here is negative x, here's positive x, and then perpendicular to that will be our y-axis. Well, that is a squeaky y-axis. And we have our negative y here and our positive y up here. So this would be quadrant 1, and we go counterclockwise. So this is quadrant 2, quadrant 3, and quadrant 4. What I'm going to try to do is draw a circle. Let's see how well I can do this. Oh, squeaky circle. Oh, that's not awesome, but you get the idea. And we see the circle intersects the x and y axes in 4 places. So this would be x is equal to 1 and y is 0. This would be x is 0 and y is 1. And down here, whoops, we have, we'll make that a parentheses. X is 0 and y is -1. And over here we have -1 for x and 0 for y. I got a little bit of room over here. We're going to make some points. I'm just going to call them A, B, and C. And without putting them on the graph, I'm going to just put their coordinates. And we'll put some parentheses and some commas ahead of time. So let's say A is at -2, 4. Well, which quadrant is this in? Well, we know the x value is negative, so we know that it's on this side of the origin. And the y value is positive, so we know it's on the upper side. So this point is somewhere in the second quadrant, because the x is negative and the y is positive. What about 3, -2? So the x is positive, so we know it's on the right side of the origin, and the y value is negative. So we know that it's on the bottom half of this. So it's in this lower right quadrant. So this would be in quadrant 4. And let's do -1, -4. So the x is negative, so we know it's on the left side of the origin. And the y is also negative, so we know it's below the origin. So it's to the left and down, so it must be in the third quadrant. Finally, we're going to draw an angle as best as I can from here to here. Now, we know from the origin to this point is 1, 1 unit long, and the same to all the other points of the circle. That's what makes it a circle. So we can draw a line from the origin to any point on the circle, and we know this will be the radius, which is equal to 1, because we have the unit circle drawn here. So let's just say that this angle, and we'll use our theta, if I can get it in there. Not really. Theta is equal to 45 degrees. Again, we use this symbol to denote an angular rotation from this point up to this point. We're rotating about the unit circle. What if we went the other way? What if we came from here, using this same starting point, but rotated this way? In this case, we're rotating the other direction. And let's just say that this is 60 degrees in here. Well, this would be negative 60 degrees because it's going the other way. It's going clockwise. And we'll get more into that in the next section. And that's it for our introduction to trigonometry. We'll go into greater detail into the unit circle and these angle measurements in our next video.